All right, guys, Mr. Antonucci here, and in this video, we're going to talk about checking the conditions for a test about a difference of two proportions. So with um, performing a test here where the proportions are equal, that's the null hypothesis, or excuse me, not where the proportions are equal, where we assume the null hypothesis is true, where the two proportions is equal. So this is a little bit different because since we are assuming that the population's proportions are equal, then we have to calculate what's called the common value of those two parameters, and we call it P. So to estimate just P, we combine, or otherwise known as pool, the data from the two samples as if they came from one larger sample. So the combined sample proportion is p hat sub c equals the number of successes in both samples combined divided by the number of individuals in both samples combined. So it's essentially x1 plus x2 over n1 plus n2. And then to get the number of successes, you just do np hat 1 and n2 p hat 2. In other words, p hat sub c is going to give us the overall proportion of successes in the combined samples. So if we go, or just want to make a note that the formula sheet includes this combined sample proportion on both sections of the AP exam. The thing is, you have to know when to use it. And the key here is that we are performing a significance test for the difference in two proportions, assuming there is no difference. So that's why we have to combine the data from the two samples, because we're assuming there is no difference in the two sample proportions. So the conditions for performing a significance test about a difference between two population proportions, same three things. Has to be a random sample, 10%, large counts. We have to be careful how we calculate these here. For the random condition, we have to verify that the data come from two independent random samples or from two groups in a randomized experiment. The 10% condition is that if you're sampling without replacement, both samples have to be less than 10% of the population. And then for the large count, you have to show that the expected number of successes and failures in each sample or group is at least 10. But notice, to get the expected counts here for the large count condition, you are not using the sample proportions from each sample. You are using the pooled proportion of the combined samples. So notice it's in here 4 times because you have to do it success and failures for the first sample and success and failures for the second sample. All right, so let's dive into a little example here. So we're throwing back to the example that we did about McDonald's and Wendy's accuracy. So of the 159 drive-through orders at McDonald's, 145 were accurate. At Wendy's, 139 of the 163 drive-through orders were accurate. We're trying to work toward determining if there is convincing evidence of a difference. The next thing we're going to do is check that the conditions for performing the test are met. So again, you can't just write the words random 10% in large counts and then hit a check mark or put a check mark there. That's not sufficient. So let's go ahead and check the random condition first. Okay, so for the random condition, you would write something to the effect of independent samples of 159 drive-through orders from McDonald's and 163 drive-through orders at Wendy's. Notice it's independent random samples because we took two different samples. The next thing we want to check is the 10% condition. And for that, we have to verify that both samples are less than 10% of the population. So it's reasonable to assume that 159 is less than 10% of drive-through orders at McDonald's, and 163 is less than 10% of the drive-through orders at Wendy's. And then finally, we want to check the large count condition. So when we check the large count condition, remember you first have to get the combined proportion. So p hat sub c, so the number of successes of each sample divided by the sample, the sample size of each sample. We get 0.882. That is going to be our combined proportion. And then we calculate and make sure that the number of expected successes and failures is at least 10 for both samples. So for the McDonald's sample, the number of successes is 140. The number of failures is expected to be 18.8. And for Wendy's, 143 and 19.2. And those are all at least 10 for this. So yes, the conditions are met for this significance test here. All right, guys, hope that was helpful in figuring out how to check the conditions. Reach out if you have any questions.